In this video, we're going to be taking a look at Quiz 2. And in Quiz 2, Observer A stands at the top of the cliff and throws ball A straight upward with a speed of 30 meters per second. So let's draw a picture of what's going on here. So we have Observer A throwing ball A upward with an initial speed of 30 meters per second. Observer B is flying in a helicopter that's going straight upward with a speed of 30 meters per second. So we got our helicopter going upward at 30 meters per second also. And Observer B, at the moment that Observer B passes Observer A, B releases ball B. B simply lets go of the ball and does not throw it. So if you're going upward in a helicopter at 30 meters per second and you let go of the ball without throwing it, but just letting go, you're not giving it any force, you're just releasing it, so you're not giving the ball any acceleration, but it was already going upward at 30 meters per second, so it's going to continue to go upward at 30 meters per second. How does the max height of ball A compare to the max height of ball B? You can use the initial velocity of ball A and the initial velocity of ball B to figure that out. What does Observer B say the acceleration of ball B is? Well, both balls have acceleration downward, and that, let's just call it little g. Well, it's equal to 9.81 meters per second square. When ball A is at its maximum height, what does Observer A say the velocity is? So this is for Observer A standing on the cliff. This is just what we learned in Physics 261 about what happens at the maximum, or Physics 161 about what the velocity is at the max height. However, in Part D, when you're talking about Observer B is going upward at 30 meters per second. So you want to use your equation here, equation 1234, and we want to know what Observer B says the velocity of ball B is. So we could say the velocity of Observer B is equal to the velocity of the ball plus the velocity of B with respect to the ball. That's the wrong way around. I want to say the velocity of the ball is equal to the velocity of Observer B plus the velocity of the ball with respect to Observer B. Oh, this is, well, it doesn't really matter. It's the ball that A threw, but it could be either ball. Okay, so this is the velocity of person B. So that would be my 30 meters per second upward. We are looking for the velocity of the ball with respect to B, and so you have to figure out what the velocity of the ball is, then plug it in here, and you can say the velocity of the ball with respect to B is equal to the velocity of the ball minus the velocity of Observer B. When the ball that B dropped, when the ball, I made some changes to your version of the quiz, so the version that I have here is worded just a little bit differently. So when ball B is at its max height, what does Observer A say the velocity is? Well, if you're talking about Observer A, you don't really need to use the equation for relative velocity because Observer A is standing on the cliff and not moving with respect to the Earth, so that would just be basic Physics 161. Okay, then in Part F, when ball B is at its maximum height, what does Observer B say the velocity is? You can use the same equation here, but now it's ball B instead of ball A. And then for Part G, does observer B ever say that ball A has a velocity of 0? If so, where does this happen? Does observer B, okay, we can actually use this equation again. So the velocity of a ball with respect to B is equal to the velocity of the ball minus the velocity of B. B is always 30 meters per second upward, and we want to know if observer B ever says ball A has a velocity of 0, so that would be the velocity of the ball with respect to B should be equal to 0. Does this ever happen? So you can plug that into the equation, plug this into here to find what the velocity of the ball would be when B says the velocity of 0, if that ever happens. Hope that makes sense. Okay, then on the next page, we have, now suppose that the helicopter that observer B is flying in also has a horizontal component of velocity. So previously, the velocity of B was 30 meters per second upward. Now, the velocity for B is still going to have that same vertical component, so that's 30 j hat. This is in meters per second, but flying 40 meters per second to the right, so that's 40 I hat plus 30 j hat for the velocity of person B. When ball A is at its max height, what does observer A say the velocity is? Well, you can figure the things out for observer A on your own. So let's look at part I. When ball A is at its max height, what does observer B say the velocity is? So again, we can use this equation here. So we know the velocity of the ball when it's at its max height. Now you're just putting in something different for the velocity of B to get the velocity of the ball with respect to B, which is what B says the velocity of the ball is. In part J, when the ball that B dropped is at its max height, that would be ball B. When ball B is at its maximum height, what does observer A say the velocity is? Well, you can figure out that one. When ball B is at its maximum height, what does observer B say the velocity is? You can again use this equation down here. A lot of these you could probably answer without using the equation, but it doesn't hurt to check to make sure that you thought about it correctly. Okay, now suppose that observer B's helicopter is accelerating upward at 9.81 meters per second squared. So now we have upward acceleration. What does B say the acceleration of the ball B is? Okay, so now we're going to use equation 1235. I want, what does A say the acceleration, what does observer B say the acceleration of ball B is? So I want to say this is the acceleration of the ball with respect to B. So B is the ball. So this is B, and this is the ball. And then what does observer B say the acceleration of the ball is? So we're going to solve this by bringing the acceleration of B over to the other side, and we have the acceleration of the ball with respect to B is equal to the acceleration of the ball minus the acceleration of B, just like the equation that we had here, but without acceleration now instead of velocity. What does A say the acceleration of the ball that B dropped is? Well, if we go back to what we have here, as long as the helicopter is still going at 30 meters per second when B releases the ball, and we're going to assume that the initial velocity is unchanged, once ball B is released, the only force acting on it is the force of gravity, so the acceleration of ball B is still going to be 9.81 meters per second squared downwards. So the fact that helicopter B is accelerating shouldn't affect what A says the acceleration of ball B is. It is going to affect what observer B says the acceleration of ball A is, and we can use this equation once again. It's a different ball, but you could put either ball in to this equation and it works. So this is what B says the acceleration of ball A is here. Okay, now suppose that B's helicopter is accelerating downwards at 9.81 meters per second squared. Well, we had the acceleration pointing upward here, so this would have been 9.81 meters per second squared in the j hat direction. So now, if the helicopter is accelerating downward, this becomes negative 9.81 meters per second squared j hat. And then you can use the same equations for this one and that one. Good luck!